Hi guys, today we're gonna solve this AMC 12 problem. AMC 12 is a high school competition and it's for 12th graders. But it's honestly not that hard of a problem because I'll show you how just a little bit of thinking before plugging in formulas before solving a problem can actually go a long way and even help you find the solution to the problem. So we'll use that strategy here. Okay, let's dive into it. For how many values of a is it true that the line y equals x plus a passes through the vertex of the parabola y equals x squared plus a squared? And the options are 0, 1, 2, 10, or infinitely many. Okay, so what is the problem asking for? Let's first see what the problem gives us. It gives us a parabola, and the equation of that parabola is y is equal to x squared, and we want to find plus a squared, and we want to find a line which is y equals x plus a that passes through the vertex of the parabola. So given this information, how can we make this problem easier? Okay, so first thing is that I noticed that the slope of the line is 1 and it's positive 1. Well, yeah, it's positive 1. And A is the y-intercept. A is the y-intercept. Okay, let me make that in a different color since it's pretty important. Okay, so A is the y-intercept. Y-int. And what do we know about the parabola now? We know that it's an upward opening parabola because the coefficient of x squared is a positive 1. That's why I drew it upward opening. And it has no left or right shift. It only shifts up and down. What do I mean by shifting up and down? So just backtracking a little bit, a squared shows us that the parabola is shifted upwards. Since even if a is negative, the fact that it's squared, it'll become positive and it'll be shifted upwards. So let's say a is equal to 1. So I have y equals x squared plus 1. That means that the parabola is just a regular y equals x squared parabola, but it's brought up 1 unit up. So if you had like if that's 1, the parabola would just start here. It would just start there. The vertex would be at 1 basically. So that means we know the vertex is at a squared. Okay, so now that we know that it's an upward opening parabola and we want a line to like intersect it, and the y-intercept has to be a squared, and both the y-intercepts are a squared, that means we know that the y value of the intersection is equal to a squared. Okay, now that we know all of this, let's now actually write some of the things we know in math terms. So first, what's the y-intercept? The y-intercept is 0, a squared. And what is the y-intercept? The y-intercept is basically kind of what we want to find. We want to find the intersection where it passes through. So let's solve that first. Okay, let's solve that first. And let's use the equation of the line. So y is equal to x plus a, and we want the y value to be a squared because that's the intersection of the y value, and x equals 0 because there's no right or left shift in the parabola. So 0, and then a just remains a because that's the y-intercept. So a squared is equal to a, and we want to subtract a from both sides. Here, let me move this down a little bit. Subtract a from both sides. Cancels out. We're left with a squared minus a is equal to 0. And factor out an a, so then we use the zero product property, which basically shows us that a is either equal to 0 or a is either equal to 1. And those are our answers. If you don't understand why I use the zero product property, it's because we want both the a and the a minus 1 terms to multiply to 0. So I noticed that if a equals 0, then this term, the a term is 0, and 0 times negative 1 was 0. And if a equals 1, then this term is 0, and then it multiplies to 0. So these are our two values for a, and that means the answer should be C, two values. So here in this problem, we actually showed that a little bit of thinking can go a long way in your competition problems, because oftentimes these problems just try to trick you and try to waste your time, even though just a little bit of thinking can go a long way. Thank you for watching.